Hello everyone, hope you are doing well. This is Ibrahim Sibgatullah over here. Now in this video, I'm going to explain you about the continuous beams. So what exactly are these continuous beams and how exactly are they different from all the previous beams that we have learnt about is what I'm going to explain you in this video. Alright, so just to have a recall of what all beams we have learned. If you people remember, we have learned about cantilever beams, we have learned about simply supported beams, fixed beams, overhanging beams, and now the continuous beams. And how exactly are they different? Okay, how exactly is the continuous beam different from all the other beams? Just in simple words, I'll tell you. The difference is that when it comes to continuous, okay, the supports over which this particular beam runs is more than 2. Okay, in simple words, if the supports are more than 2, okay, if the beam runs over more than 2 supports, then such type of beams are called as continuous beams. So what are we going to do in this unit? We are going to learn how to draw the shear force and bending moment diagram for a continuous beam. Okay, and for that there is a method called Clapeyron's theorem of 3 moments. Okay, so why exactly are we going to need Clapeyron's theorem of 3 moments? The big reason is that this theorem will help us to find out the bending moment, okay, the bending moment diagram for a continuous beam. Okay, in simple words, the support moments are required to draw the bending moment diagram. Okay, and the support moments can be determined by using the Clapeyron's theorem of 3 moments. And what is the benefit of this theorem? It helps us in finding out the bending moment of 3 supports. Okay, this is the benefit and this is also the limitation. Okay, we cannot do more than 3 supports. Okay, we cannot find out the bending moment of more than 3 supports. But what will be the solution when there are more than 3 supports? Let's say there are 4 or 5 supports. This I'll be showing you in the continuation of these videos. Okay, so today in this particular video, we are going to learn about the Clapeyron's theorem of 3 moments, and also I'll be explaining you about the steps which we need to use in order to solve the problems of this particular topic. Alright, so let's move on. So now coming to the Clapeyron's theorem of 3 moments, as I have just explained you, we can only, the limitations are we can only use just 3 supports at a time. Okay, so let's say there are 3 supports. Okay, I'm going to start with explaining 3 supports and then we will move on to 4 supports as well. So let's say this is point A, this is point B, and this is point C. There is a UDL over here. Okay, there is a point load over here. See, when it comes to the loads, you already know that there are 2 types of loads that we are going to learn as an architecture student. Okay, one is the uniformly distributed load, and another is a point load. There is also one more type of load called uniformly varying load, but thankfully we don't have that particular load in our syllabus. Okay, but when it comes to point load, we have 2 different types of point loads. Okay, one is the point load that acts exactly at the center, and a point load that exactly that does not acts at the center. Okay, so anyways, that I'll be explaining you when we are doing the problems, but for now let's focus on what exactly is the Clapeyron's theorem of 3 moments. So Clapeyron's theorem of 3 moments, okay, if A, B, and C are the 3 supports of a continuous beam, then the relation between these support moments, okay, as per the Clapeyron's theorem of 3 moments, is given by MAL1 plus 2MB L1 plus L2 plus MCL2 equals to 6A1 x1 by L1 plus 6a2 x2 bar by L2. Okay, so this is the formula that we have to use whenever we are calculating the moments. Okay, whenever we are calculating three moments. Okay, the support moments of three supports. This is the formula that we have to use. Let's say we got a problem that has one more support D. Okay, so in this case, what is the solution for that? What are we going to do? Okay, the solution is very simple. Okay, there is just one simple trick that we have to use, which is we have to divide this into two parts. Okay, so in the first part, we will take ABC. In the second part, we will take BCD. Okay, calculating the support moments of supports ABC. Then we will calculate the support moments of support B, C, and D. And what will be the difference? The difference will be in the formula. Okay, so when we are doing for the supports A, B, and C, this will be the formula. And when we are doing it for support B, sorry for that, B, C, and D, the formula will be like we will replace this. Okay, so MA is moment at A, L1 is this distance. Okay, this is L2 and this is L3. Okay, so when it comes to calculating the support moments of the supports B, C, and D, we just have to replace these things. Okay, so this will be MB L2 plus 2MC L2 plus L3 plus MD L3 equals. So this will be 6A2 X2 bar by L2 plus 6A3 X3 bar by L3. Okay, this is the only difference. Now, if you are able to understand this difference, then no matter how many supports are there in the question, you can literally just solve them. Okay, usually in the exams, we usually get up to 4 supports. Okay, A, B, C, and D. Sometimes, if the paper setting person is in good mood, he will just give you, 3 supports, A, B, and C. But now that you know what is the trick that we have to use, you will be able to do it no matter how many supports they are going to give you. Okay, so now coming to elaborating these things. Okay, this thing, then this thing, then over here. Okay, so what exactly are these? Let's start with, okay, now just looking at this thing for now. Okay, just to explain you what these things are, I'm explaining it to you with reference of these things. Okay, but the same thing will apply over here. There is no difference. Okay, so I'm just elaborating what all these points are. So coming to MA, MB, and NC, these are the movements at support. Okay, these are called as support movements, and this is what we will be finding out. Okay, we are finding out the support moments. So MA, MB, and MC are the support moments of the supports A, B, and C. Then coming to L1 and L2. Okay, we just have L1 and L2 over here. So coming to L1 and L2, these are the lengths between the span AB and BC. Okay, since we are taking the supports A, B, and C, we will have two spans. Okay, we will have one span as AB and we will have another span as BC. All right, so this L1 and L2, these are the lengths between the span AB and BC. Okay, L1 is the length between the span AB and L2 is the length between the span BC. All right, so this is about the left hand side. Now moving on to the right hand side, we have A1, we have A2, we have X1, we have X2. Okay, so coming to A1 and A2, like when we are when we are going to do the first step, like I'll be explaining what the step 1, step 2 is. So after we are done with this, okay, after we are done with the step 1, we will draw the bending moment diagram. Okay, so that particular bending moment diagram will have some particular shape. Okay, it will be a parabola, it could be a triangle as well. So what we will do is when it comes to A1 and A2, depending on how the bending moment diagram appears, okay, whether it looks like this is a parabola, or whether it looks like this is a triangle. Okay, we usually get a parabola when we are drawing the bending moment diagram under a UDL, and we get this triangle when we are doing the bending moment diagram for a point load. Okay, so depending on how this area looks like, okay, how this shapes look like, we will be calculating the areas. So A1 and A2 is the areas of bending moment diagram under that particular under that specific span. So let's say in this case for span AB, okay, once we are done calculating, we will get a diagram under this span. Okay, and then when we are calculating BC, span BC, we will get one more diagram under this span. Okay, I'll be showing that to you how we have to draw all those things when we are in the problem. So when it comes to span, because of the load which is acting over it, there is going to be a diagram. So A1 is the area of the bending moment diagram under span AB, and A2 is the area of bending moment diagram under span BC. Okay, now coming to X bar and X1 bar and X2 bar, these are the centroidal distances of the bending moment diagram. Okay, so let's say X1. So what exactly is this X1? Let me just zoom into this. So let's say that we have got a bending moment diagram over here. So this is the bending moment diagram. Okay, so X1, okay, we have L1 under AB, we have A1 under AB. Now coming to X1, X1 is the centroidal distance of the bending moment diagram of AB from A, okay, from the end support, from the far end support. Okay, so this is L1, so X1 will be half of it. So if, for example, this is 6 meters, so X1 will be 3 meters. Okay, now moving on to X2. Let's say we have got a bending moment diagram over here that is a triangle. Okay, so now coming to X2, X2 will not be here. Okay, this is not going to be X2. No, X2 will be this distance. Okay, X2 is going to be the centroidal distance from the center of the bending moment diagram to this end, okay, to the right end. Okay, if we are taking ABC, between AB, it will be at A, between BC, it will be at C. But let's say we are taking for BCD. Okay, we will be doing the same thing. Like for A, B, and C, we calculated from A. For for AB, we calculated from A. For BC, we calculated from C. And the same thing will apply for B, C, and D also. So when we are calculating the bending moment diagram of BCD for span BC, now it will not be till C. Okay, it will be this one now. Okay, because the same thing we have done for AB and BC also. And then when we are calculating for CD, okay, let's say we have a UDL over here, and this is a parabola. Okay, so for CD, okay, for span CD, we will not take from here to here. Okay, we will not take it like this. No, we will take it like this, from here to here. Okay, so whatever the value of L1 is, half of it will be x2, x1, x2, whatever we are doing. But there is a slight difference when we are doing the point load, which is not exactly at the center. Okay, so there is a simple formula for that, which I'll be explaining to you when we are doing the problems. Okay, so this was about the Clapeyron's theorem of three moments. Now moving on to the steps that we are going to do over here, there are very simple steps, but there is a variety over here. Okay, like the continuous beams are not just continuous beams. We have two different types of continuous beams over here. So one continuous beam, okay, there is one continuous beam which runs over simple supports. Okay, so we call this as simply supported continuous beam. Then there is one more type of beam which has fixed supports. Okay, so we will call this as continuous beam with fixed supports. Okay, this is continuous beam with simply supports. Okay, simple supports, and this is continuous beam with fixed supports. So now coming to how do we calculate the problems. Okay, this is very important for you to know. So just pay attention over here. The reason why I am asking you to pay attention over here is because if you are able to understand the steps which I'm going to explain you now, then you will be able to solve the problems of two other units also. Okay, there is a unit called moment distribution method. There is one more unit called rotation distribution method. Okay, so if you are able to understand the continuous beam steps, then you will be able to do the steps for the other two units also. Okay, so in one shot, you will be able to score 30 marks just by understanding this particular problem. Okay, so in step one, what we will do? In step one, we are going to calculate the span moments. Okay, moments on the span. So if we are calculating for AB, okay, so we will have to calculate the span moments over there. Okay, so we have to consider two things. One is what type of beam it is. Okay, when we are calculating the span moments, there is there is an important thing that we have to consider. Okay, so the first thing is we have to find out what is the type of beam. Okay, and what type of beam it could be. It could be a simply supported beam. It could be a cantilever beam. It could be a fixed beam. Okay, like this is what we consider when we are talking about moments. So in our case, it could either be a fixed beam or it could be a simply supported beam. Okay, so the first thing that we have to consider while calculating the moments over the span is the type of beam, and the second thing is type of load. Okay, so depending on these two things, there are specific formulas to calculate moments. So whenever we are calculating the span, we will use that particular formula depending on these two criteria. Okay, what type of beam it is and what type of load it is. Okay, so this was step one. Now coming to step two, we will be calculating the moments, but not over the span, but over the supports. Okay, and how do we calculate that? We will calculate the support moments using the Clapeyron's theorem of three moments. Okay, and once we are done finding out, we will then move on to step 4, where we will calculate the support reactions. Okay, and why are we going to calculate the support reactions? Because the question also asks us to find out the shear force. Okay, so without understanding what are all the loads which are acting over that beam, we will not be able to find out the shear force. Because to find out shear force, the reactions at the supports are very important. Okay, and what are the reactions? These are the internal forces that gets generated due to the external forces. And what are the external forces? The loads. Okay, the uniformly distributed load, the point load, all these things are the external forces, and to counter them, the beam will give an internal reaction. Okay, this is what we call as support reactions. Reactions from the supports to handle the loads which is falling on them. Okay, so once we are done calculating the support reactions, then we will calculate the shear forces. All right, so step one, let me repeat it once again. We will calculate the moments over the supports based on what type of beam it is and based on what type of load is acting over. Then we will we will draw the bending moment diagram. Then we will calculate the support moments using the Clapeyron's theorem of three moments. Then again, we will complete the bending moment diagram. Then in step 3, we will move on to the support reactions. Then in step 4, we will calculate the shear force. And then after that, we will draw the shear force diagram. Okay, so this is what we will be doing for the simply supported continuous beams. Okay, these are the supports, these are the steps that we have to remember. Now, there is not much a difference when it comes to the fixed continuous beams. It's that the only thing that we will do is when we are calculating the support moments using the Clapeyron's theorem of three moments, what we will do is we will assume one imaginary span before the fixed end. Okay, whatever the fixed end is, just before the fixed end, we will imagine an imaginary span. Okay, the load will be zero, the span will be zero, whatever load is acting over there, that will be zero only. In fact, the bending moment diagram for that, the area, even whatever we are taking, okay, we will take it as A0, and that will be also zero. X, that will also be zero. L, that will also be zero. The load will also be zero. Okay, because it is just an imaginary span. Okay, so I will be explaining all these things to you when we are doing the problems. Okay, everyone. So that's it for this video. In the next video, I'm going to teach you how we can solve the continuous beams which are simple supported. All right. So I'll see you all in the next video now.